In this video, we're going to talk about Pythagorean theorem, special right triangles, trigonometric functions, and trig ratios of special angles. So, if you remember, your Pythagorean theorem is a squared plus b squared equals c squared. And then you're going to find the missing side. I'm only going to do one because, I'm going to stick with the odds here. So 4 squared plus 8 squared equals x squared, because your hypotenuse is always across from the right angle. So you have 16 plus 64 equals x squared, or c squared. So 80 equals x squared. So then if you simplify 80, you get x equals 4 square roots of 5 when you simplify your radical. Alright, then we have special right triangles. So we have a 45, 45, 90 triangle and a 30, 60, 90 triangle. So on a 45, 45, 90 triangle, these legs are the same. So they're both x. And then your hypotenuse is x, whatever length x is, and then you take it and multiply it by the square root of 2. And then 30, 60, 90, your side across from your 30 is going to be your shortest one. So that's x. Your side across from your 60 will be the longer one, x squared root of 3. And then your hypotenuse will be 2 times the shorter leg. So, and then we are going to do a few of these. We'll do a couple of each. So, number 3 here, I have to sneeze. Maybe. Excuse me. Number 3 here, we have a 45, 45, 90 triangle. We know that one of the sides is 10, so the other side is also 10, because those sides are the same. And then your hypotenuse would be 10 square roots of 2. And then 6, we'll just do these odds here. We have our hypotenuse, which is 14 square roots of 2, so then both of you would take 14 square roots of 2 and divide it by square root of 2, so those just go away and you get 14. So both of your legs are 14. And then, last but not least, we have the side across from the 60, which is x squared of 3, is 27. So you would take 27 and divide it by square root of 3, which doesn't work. So you have to multiply both sides by square root of 3. So you get 27 square roots of 3 over 3. 27 over 3 is 9, so 9 square roots of 3 would be your shorter side, because this is the 30. So this would be your shorter side, so 9 square roots of 3. Then you're going to take that and multiply by 2, so you get 18 square roots of 3. And then trigonometric functions. I really like this. It's SOHCAHTOA. I'm sure some of you have heard of it before. I'll zoom in. So, SOHCAHTOA. Or some old hippie called another hippie tripping on acid. Either way, whichever way you wanted to look at that. So, a trigonometric function is a function whose rule is defined by a trigonometric ratio. And then this ratio compares the length of two sides of the triangle. We use theta, which is this little circle with a line through it. But don't call it a circle with a line through it, call it theta. Is used to represent the measure of an acute angle in a right triangle. So sine, this is where SOHCAHTOA comes in. Sine is opposite over hypotenuse. And then cosine is adjacent over hypotenuse. And tangent is opposite over adjacent. And then cosecant, secant, and cotangent are just the reciprocal of the one above it. So this would be hypotenuse over opposite. So you just flip the fraction. Hypotenuse over adjacent, and then adjacent over opposite. So we're just going to do one. We're just going to do number 9 here. So I need to find the hypotenuse first. So 16 squared plus 30 squared equals c squared. So 256 plus 900 equals c squared. So then I get 1156 equals c squared. So c is 34. So c is 34. And we're using this angle here, which matters because if I use this angle instead, my opposite and my adjacent would be different. So sine is opposite over hypotenuse. So that's 16 over 34, which simplifies to 8 over 17. And then you can flip it if you want. You can go ahead and do the reciprocal, which would be 34 over 16, which is 17 over 8. And then cosine, I just did cosecant. Cosine is adjacent, which is 30 over 34, which simplifies to 15 over 17. And then secant would be 34 over 30, which is 17 over 15. And then tangent is opposite over adjacent. So 16 over 30, which simplifies to 8 over 15, which would make this 30 over 16, which is 15 over 8. So if you wanted to do it, that's how you would do that. Then trig ratios of special angles. So these are our 45, 45, 90 triangle and our 30, 60, 90. So remember that our legs are the same. 1 of 45, 45, 90, and then our hypotenuse is times the square root of 2. And then for our 30, 60, 90, the shorter one's across from the 30, and then x square root of 3 is across from the 60, and then 2 times x is across from the hypotenuse. So these will be used frequently. We'll use them a lot. I'll show you how they work together with a unit circle when we get there. So sine of 45 would be x over x square root of 2, because you take opposite over hypotenuse. So then when you simplify it, you get square root of 2 over 2. And then same thing if you did it with cosine, because the sides are the same. And then tangent of 45 would be x over x, which is just 1. So then we're gonna do, I used this triangle to do that with. And then we're going to do sine of 30. So we're gonna use this angle here. Let's use that angle. So sine of 30 opposite over hypotenuse. So x over 2x. So the x's go away and I get 1/2. Cosine of 30 would be x over square root of 3 over 2x. So then you have to simplify that. The x's still go away, so you get square root of 3, not square root of 2. Square root of 3 over 2. And then tangent of 30, you would have x over x square root of 3. And when you simplify that, you get square root of 3 over 3. And then similarly, it'll work for 60 degrees, except here, let's erase the, maybe, no, not gonna work, okay. So if we wanted to do 60 degrees, let's go use green, so cosine and sine are gonna switch. So I'm gonna have square root of 3 over 2 and then 1/2, because they're just gonna flip-flop. And then tangent x square root of 3 over x, which will give me square root of 3.